This is the third video in our AWS Developer Infrastructure series. We're going to show how we can set up a Lambda function that can call framework dependencies and reusable code from what's known as a Lambda layer. The code will be very similar to the previous video. You can find more details about AWS Lambda layers at the link provided here. Our local stack development stage will be impeded by local stack's lack of support for Lambda layers. We will use a new class to create our Lambda function, Gateway Report Handler. Similar to API Gateway Handler, it will use the API Gateway input and output events. This is a much more involved class that will call dependencies, framework dependencies like PDF libraries and other artifacts like images to embed into a PDF file. The code here represents the function code independent from the layer. This is the new code for the Lambda layer. First we have a report generator class. This will call framework PDF code, open PDF. While it's not as big as Apache PDF box, it's a major dependency. Report generator also uses images that are stored in the layer. Once the report generator class has generated the report, Gateway Report Handler calls down into the layer to use the S3 Lambda client class to push the completed PDF report into an S3 bucket. The S3 Lambda client pulls in the AWS Java SDK S3 dependencies. It's important to note these S3 dependencies are not contained within the function code. Lambda layers allow us to encapsulate reusable code and their associated dependencies into an artifact that can be called by many Lambda functions, and all the dependencies are encapsulated in the layer. This is a summary of our class path architecture, if you like, where the Lambda function calls down to the layer for major dependency and other artifacts such as reusable images, corporate logos, etc. Create a layer, very similar to how we create a function. We give it a runtime and we have a shadow jar with all our compiled layer code and translate that jar to a byte buffer which we attach to the layer. We have new parameters, layer arn, we call for after we've created the layer, and we need to tag the version on. We need to be aware of this Lambda timeout. Once we've created our API Gateway and Lambda function, when we call it, the Lambda function needs to complete within the maximum API Gateway timeout, which is 29 seconds. The only way to get past that is to call our Lambda function asynchronously. This means we have to use a completely different API Gateway setup, which is a bit beyond the scope of this video. Generating any kind of complex PDF report can be CPU intensive, memory intensive, and take a while. So it can be a challenge to get past this Lambda timeout limitation. The only way to get past this when calling the function synchronously is to increase the CPU and memory. This is a function that works with the new parameters. Set a request timeout of 29 seconds, the max allowed, and we increase our memory size to 256 megabyte. The CPU power is linked to the memory size. We map the function to the layer by passing in the layer arn with version. We need to isolate the compile time dependencies from the runtime dependencies. When we compile the code, our function code will need to find the code in the layer. But when we push the layer and the function code to AWS, we want them completely separate. To have any artifacts existing simultaneously in the function code and the layer completely defeats the purpose of having a layer. Here we can see, in order to build the function code, we need to import the Lambda layer as a dependency into the function code. Our problem is now that our Lambda layer code will end up in the shadow jar for our function code. We can fix this by filtering out all the Lambda layer artifacts and dependencies. The shadow plugin provides us with this shadow jar closure where we can perform these exclusions. We can exclude all the artifacts like images. We can exclude the entire set of classes, class path dependencies, framework dependencies. We can exclude all the infrastructure code, and we can exclude the Kotlin library. Now that we've highlighted all the new parameters, we're ready to actually run the code off local stack and then on AWS. It will run just as in the last video. Main differences are now that we have this Lambda layer that provides dependencies to our Lambda function, and the Lambda function will use the layer to generate a PDF report and push that report to S3. We start as before by running local stack. We have two services as the previous video. We've configured our code in such a way that when we run it against local stack, it's not going to run the layer. So we're running the code against local stack. So we'll check that we've configured our gateway successfully. So we'll use the client to check, do we have a REST API ID? And we find that we do. So we grab the new REST API ID and delete that. So we just check, do we have our new report handler? We can see our Lambda report test function is there. So we want to delete that function now. So now we've gone as far as we can with local stack. We're going to run the code against AWS. Now we haven't had a chance to test our layer code locally. What we will find is it takes a while for the layer code to set up. Once you get past the layer part of this setup, and the rest of the code, deploying the function code and the API gateway, goes quickly. Set up the layer correctly. Now it's completed just as before, and it's given us our URL we can use for testing with curl. Run a post request to the API gateway endpoint. Now this is going to take a while. Doesn't complete within 29 seconds, we will get a timeout exception. So it called back, it authenticated the token. This means the handler completed successfully. So we should be able to find everything on AWS is set up. Now we will go to the console, go to the Lambda service, check is our function there. Look at the function, we go down, check the layers. So a layer is attached. Go to the monitoring, we can check out the CloudWatch logs. And it's still on a previous version. It can take a couple of minutes for the latest logs to come through. So now I can see I have a new entry, so this is the latest log. Looking at the logs, I can see handle report made a successful S3 put, so that means everything worked. Now I go to S3, I go to this bucket, Lambda PDF report, and I can see I actually have the Lambda report that I've generated. So now I'm going to download this report and check that it's not just junk. And there is the report. I've concentrated on getting all the system attributes for the Lambda runtime that I can. It completes this report inside the 29 seconds. A typical corporate report would be much more for this, so you might need to increase the memory from 256 to. But if you can't get it to work inside the 29 seconds, even increasing the memory up to a considerable cost, then you would look at setting up the Lambda function to run asynchronously off the API gateway. Just a quick check of the function parameters. In particular, the timeout was set to 29 seconds. It matches the API gateway. We'll have a look at the default timeout. So we can find the default timeout setting. Integration request, we can find the default timeout is 29 seconds. Now finally and importantly, we clean up all the artifacts that we have constructed on AWS. We need to make sure we delete the report from the bucket. So as before, we just delete everything and double check on AWS that everything was deleted successfully.